All right, class. Today we're going to cover Objective 5 for Math 131. For Objective 5, we're going to use the rules of exponents to multiply and divide monomials, okay? So first of all, a monomial is a number, a variable, or a product of a number and variables. The degree of a monomial is the sum of the exponents on the variables. For example, x to the n would have the degree of n. The degree of a non-zero constant term is 0. For example, the degree of a number like 6 would be 0. So here are some examples that I want us to look at. First, we have x. Now, whenever we have just a variable or just that letter by itself, the exponent on that is 1. So in this case, the degree of x would just be 1. If we had 3x squared, 3 is a non-zero constant term. So the degree on that will be 0. And x squared, the degree on that will be 2. We'll add those together to get the degree of 2. Next, if we had 4x squared y, the degree of 4 would be 0. The degree of x squared will be 2, and the degree of y will be 1. When we add that all together, we will have degree 3. And for the last one, if we had 6x cubed y to the 4th power z squared, the degree of 6 is 0. The degree of x cubed is 3. The degree of y to the 4th is 4. And the degree of z squared is 2. So when we add all of those together, we would get degree 9, okay? So now we're going to talk about the rules and how to use them, and we have 7 of them to cover. So rule number 1 is x to the m times x to the n equals x to the m plus n, okay? So what this means is if we have two things being multiplied with the same base, for example, if we had x cubed times x to the 4th, they have that same base of x, okay? So that means that we can just add those exponents. All right? So that is what this rule means, okay? So let's look at some examples. So for example 1, let's look at z times z to the 6th, okay? So whenever we have the variable by itself, we know that it's to the 1. So what we are really looking at is z to the 1 plus 6, which is going to be z to the 7, okay? For example, 2, we can do it with multiple things, okay? But as long as they have that same base, the same base of b, we will just add all of those up, and it will be v to the 10, okay? So that is how that works, okay? We can also have a situation where it's written like this. Okay. This group is being multiplied by this group. So it's kind of like we have 4 things being multiplied together. So everything that has that same base of A, we will look at those exponents and add those. Everything that has the same base of B, we will look at those exponents and add those. And so the final answer will be A to the 7th, B to the 12th, okay? And for the last example, under rule number 1, I want to show you what it's like if we have a number in front. So for example 4, if we had negative 4 x to the 5th y cubed times 3xy squared, we would multiply the numbers together and then put the ones with the base of x together. Then we will put the ones with the base of y together, okay? So negative 4 times 3 is going to be negative 12. Then we have the x to the 5 plus 1 and the y to the 3 plus 2. So our final answer is going to be negative 12 x to the 6 y to the 5th. Okay? So that is how we do rule number 1. All right, for rules 2 and 3, they are kind of similar, all right? So we're going to look at these together. So let's imagine we have a squared cubed, okay? We know that this means a squared times a squared times a squared, which what we just talked about, we could do rule number 1 and get a to the 6 like this by adding those exponents, 2 plus 2 plus 2 to get a to the 6, okay? But with rule number 2, if we have a squared cubed, if we follow the rule, the exponent being 2a exponent, we can multiply those, okay? So it'll be a to the 2 times 3. And that is like a shorter way or a shortcut per se to get to a to the 6. And this is if we use rule number 2, okay? So when you all see certain problems, some of you are going to want to use certain rules over other rules, okay? Everybody will kind of look at these problems a little differently, which is why it's important for you to know all 7 rules, because depending on the problem, one particular rule may stand out to you over the other ones, okay? As long as you use the rules correctly, it doesn't necessarily matter which rule you use. Some situations, you will see after we go through all 7 of them that, in some situations you will have to use such and such rule, but a lot of them are really interchangeable, okay? It's, multiple ways to do it. So let's look at another one. So for this one, if we had x cubed y to the 4th squared, all right? We could do this one by doing rule number 1. We can write this twice and then gather those common exponents, well, the common base, and figure it out like that, okay? When we have them multiply, everything wrote out that's multiplied, that's when we can add the exponents. Again, this is rule number 1, okay? And I'm doing this because a lot of people get this confused as to when to multiply the exponents and when to add the exponents. So if we want to do rule number 3, pay attention to how we are starting from the point where we have exponents to an exponent. We can do rule number 3. And based off of rule number 3, we will have x to the 3 times 2 and y to the 4 times 2, okay? So with rule number 3, it's like we're bringing that exponent in, okay? In a previous class, somebody said it's kind of like the distributive property. If that's a easy way for you to think about it and kind of remember what you're supposed to do, then okay. So when we simplify this, we will have x to the 6 and y to the 8. Same thing we got over here. we just used a different rule. So that is how you work rule number 3. For rule number 4, this is when we have a fraction involved, okay? So if we have x to the m over x to the n, we will subtract those exponents, okay? And there's also another way that we can look at this. Let's say we had x to the 9th over x squared. If we follow this rule here, since we have that same base of x, we can subtract the exponents. It will be x to the 9 minus 2, which will give us x to the 7, okay? Another way that we can think about this is, what if we had 9 x's in the top and 2 x's in the bottom, okay? We know that anything over itself is 1, or anything divided by itself is 1. So we can kind of cross these out. X over x is going to be 1. X over x is going to be 1, okay? So by doing that, we were able to get rid of 2 x's from the top and the bottom. And we're left with 1, 2, 3, 4, 5, 6, 7 x's in the top. Okay? So in some situations, it's easier to think about rule number 4 like this. Okay? Some of you will always look at it and think about subtracting the exponents. For some of you, thinking of it in a more logical way, with like if we got 9 in the top, 2 in the bottom, we can get rid of 2 from the top and bottom, and we'll just be left with 7 in the top, okay? For some of y'all, that will make more sense and be easier. Definitely when we get to rule number 6, okay? Another thing about rule number 4 that is going to lead us into rule number 5. What if we had x to the 4th over x to the 4th? If we follow this rule, we'll have x to the 4 minus 4, which is x to the 0, right? But also, again, anything divided by itself is going to be 1. So x to the 4th over x to the 4th is going to equal 1, right? So with that in mind, that will take us to rule number 5. Rule number 5 is x to the 0 equals 1. So with this, we want to make sure that we are being careful and paying attention to what we really have, okay? If we're looking at 27 to the 0, that's 1. If we have negative 16z cubed in parentheses, it could be anything inside of these parentheses. If it's to the 0 power, the answer is going to be 1, okay? The issue arises when we have something like this, negative 15 to the 0 power. We want to think about what is actually to the 0 power. It is the 15, not the negative sign, okay? So this means that we have a negative sign and that 15 is to the 0 power. So the answer to this is going to be -1, okay? The same with if we had 3z to the 0 power, okay? What this is 3 times, and then the z to the 0 is going to be the 1. So the final answer is going to be 3, okay? So with rule number 5, you want to make sure that you understand clearly what is to the 0 power. That's the only thing that's going to be 1, okay? Now with these two problems, if in parentheses it clearly stated that the -15, all of that was to the 0 power, then of course it would be 1. If the problem clearly stated by putting it in parentheses that the 3z was to the 0 power, then of course that would be 1 as well. So that is how we work rule number 5. Now we need to look at rule number 6. Rule number 6 is going to involve fractions again. And the important thing to remember about rule number 6 is that we do not want to have a negative exponent, okay? So if the exponent is negative, the way we make it positive is by moving it. If it is in the numerator, we will move it to the denominator to make it positive. And if it's in the denominator, we will move it to the numerator to make it positive. Okay, so let's look at some examples of that. So this problem right here, x to the 4 over x to the 6, okay? Let's say we do rule number 4 and we subtract the exponents. We will have 4 minus 6, which will give us x to the -2, okay? Since we don't want that exponent to be -2, we will put it in the denominator, okay? So x to the -2 will now be 1 over x squared, okay? Another way to think about this, and this is if we use rule number 4 up here, and then we did rule number 6. So another way that we can think about this is more from like a logical standpoint, okay? If we have 4 x's in the top and 6 in the bottom, the most that we can get rid of from the top and the bottom would be 4, right? 4 x's over 4 x's is going to be 1, and we would be left with what? What's left? In the numerator, It looks like we don't have anything, but the only thing that's up there is 1. And in the bottom, we have 2 x's. So logically, we were able to see and understand why this is the answer. Okay, I want it to logically make sense for you all. I don't want y'all to just memorize the rules. Okay, this is why we get the rules or the quote unquote, shortcuts, because they logically make sense. Okay, so this is how rule number 6 works. The thing with this one, of course, if we had 4 to the negative 3, we can easily do 1 over 4 cubed, okay? The issue with this rule is if we have something like 2z to the negative 5th, we want to make sure we understand what that negative power belongs to, okay? So if your thought is to do 1 over 2z to the 5th, that will be incorrect, okay? The z is the only thing that is to the negative 5 power. So we do not have to move or mess with the 2. So we will leave the 2 in the numerator, and we will just put the z to the 5th in the denominator. Now, if the problem tells us by putting it in parentheses that the 2 and the z are to the negative 5th power, then and only then would the answer be 1 over 2z to the 5th power. Okay, so the same way with the exponent of 0 for rule number 5, we want to make sure we understand what the exponent actually belongs to, okay? And let's look at another example. Let's say we had 7 over a to the negative 6. The answer to this, that 7 is in the numerator, and that a to the negative 6 that's in the denominator, we will bring that up to the top so that that 6 can be positive now, okay? So that is how we do rule number 6. Now, last but not least, we have rule number 7. Rule number 7 has a lot of different parts and variations. So, the first and simplest way, let's say we had x over y to the m power, okay? The same way we kind of thought about it earlier, that exponent of m, we can kind of put that in to both of those to get x to the m, y to the m, all right? If we had x to the m over y to the n to the p, we could put that p in to both of those and get x to the np over x to the np, okay? The other part of rule number 7 kind of has rule number 6 included. So if we have x over y to the negative m, we can do the reciprocal, okay? And when we do that reciprocal, it's going to make that m go from a negative m to a positive m. And then from there, we can do rule number 7. Another way to think about it is if we go ahead and put the negative m in, it'll be x to the negative m over y to the negative m. And then to make the m's positive, we will have to move the x to the negative m down and the y to the negative m up. And we will get this right here in both of those situations, okay? So let's look at a problem. So first, if we have a to the second over b to the fourth to the fifth, okay, we can multiply that exponent in to both of those, and we'll have a to the 2 times 5 and b to the 4 times 5, which will give us a to the 10 over b to the 20, okay? If we had it with a negative exponent, let's say x cubed y squared over, well, to the negative 4, we can multiply it in right away. While it's still negative, and we will get x to the negative 12 over y to the negative 8, and then we can swap them to make them positive. So it's really up to you again. It's how you look at it, how you kind of interpret it, what you think will be the easiest way for you, okay? Some of you from this point, you will look at it and you will go ahead and do the reciprocal and make that exponent of 4 positive, okay? Either way, you should get to the correct answer, okay? And these problems can get a little lengthy and a little complicated. And you will have to use probably multiple rules in some of these problems. So let's look at this one. Okay. So we have 3ab to the negative 4 times negative 2a to the negative 3b to the 7. Okay. So what I would suggest is to go ahead and do your grouping, or, determine your like bases and everything and start there. So we'll have to do the 3 times the negative 2. We'll have to do our things that have the base of a. So we'll have the exponent of 1 plus the exponent of negative 3. Then we can look at the things that have a base of b. We have negative 4 plus 7. Okay? So when we simplify a little further, the 3 times the -2 is going to be -6. The a to the 1 plus -3 is going to be a to the -2. And the b to the -4 plus 7 is going to be b to the 3rd. Now we have this right here that we need to work on because this a is to a -2 exponent, and we don't want that. So to fix that, we're going to keep the -6 and the b cubed in the numerator where it is, but we're going to put the a squared in the bottom. So this is how we work rule number 7. So now that you have seen all 7 rules, you should be able to tackle some of the more complicated problems where you will have to use multiple rules to figure out the answer. All right.